All right, here's another example. Kind of the same idea, but maybe a little easier than one. I don't know. A block of mass 3 kilograms slides down an inclined plane. Okay, so let's make that positive. At an angle of 45 with a massless tether. Okay, that means we don't have to worry about the string, right? Because that makes it way more complicated. Attached to a pulley with mass 1 kilogram and radius 0.5. Okay, this is telling you have to include the pulley. Okay, at the top of the incline. The pulley can be approximated as a disc. That's another way you're knowing you have to do it. The coefficient of friction is 0.4. What is the acceleration of the block? Okay, so I assume there must be some like string wrapped in here or something so that it can let it out, right, and can push that block down the plane. Okay, all right, so first of all, we have the block. Okay, so we're going to have Fg of the block, Fn, okay, and then this direction, we have the tension, okay, and we have the friction, okay, because the block is moving down, so we know the friction is going to be up the hill, all right, and then on the pulley itself, all right, we have the only thing that's acting at a distance, right, from the center is this tension, okay, and those are going to be equal, right, because that's the same rope doing the same thing. Okay, so for this one, we only have to worry about that because whatever this other force is here, right, is sort of acting like at the radius. So we don't have to, that's not making the pulley spin. Okay, the only thing making the pulley spin is this force of tension out here. Okay, this is actually a lot easier than the other one, I think. All right, so I want to go back to my old skills, right, and I want to make sure that I first put this on the axis. Okay, so Fn. Okay, Ft, Ff, and then my Fg is kind of on this angle. Okay, which means I'm going to have an Fgy this way and an Fgx this way. Okay, and then that would negate that one. All right. Okay, so I'm going to write some of the forces in the x equals max. This is for the block. Okay, so I'm going to have Fgx minus the tension minus the friction equals m of the block, ax. Okay, and then I'm going to have some of the forces in the y for the block, but that equals 0, right? Because up and down, those are going to have to be equal. So Fn is just going to equal Fgy, or Fg cos theta, right? Okay, and then I'm going to have the pulley is going to have a torque equation. Sum of the torques equals I alpha, and the only thing that it has is that tension at the edge. Oops. Equals, this is still a disk, 1/2 mr squared times alpha. Okay? All right. So now I have 3 equations. I don't know the tension, and I don't know the acceleration, and I kind of don't know the friction, right? But I can get that using this. Okay? So I think what I want to do is I just maybe want to rewrite this first. Okay, so this is going to be, I'm just going to put m block g sine theta, right? Hopefully that inclined plane thing should be easy by now. If not, you need to go back and review that because you should be able to do that quickly. Minus ft, oops, not equals. Okay, minus ff, right, which is just mu times the normal force, okay, which is that. So that's mg cos theta, mg, right? Okay, and that's going to equal mass of the block times ax. Okay, all right, so now I have 2 equations, right? Here, my only unknown is ft and alpha, and here my only unknown is ft and acceleration. Okay, but remember, those 2 can always be put together, right? Because the acceleration is just alpha, alpha r, or alpha equals acceleration over radius. Okay, so I'm just going to put that right there. Okay, so my ftr equals 1/2 mr squared times the acceleration over the radius of the pulley. Okay, and again, see, those cancel, and now those cancel, right? So my ft is really just 1/2 ma. All right, and that pretty much always happens, right? All that stuff's going to cancel out and get rid of some of that stuff, which is another good reason not to put the numbers, right? Because a lot of stuff might cancel. Okay, all right, now I'm to the point where now I know this, I can just throw this in here, and now I'm down to 1 unknown. Okay, so mBg sine theta minus 1/2 m, that's the pulley acceleration, okay, minus mu, that's the block, cos theta equals mass of the block A. I'm just going to get rid of the x, right, because we're only talking about one now. All right, and now I'm probably just going to go ahead and put the numbers, although you could be slick and go through. Again, what are we even finding? Acceleration probably? Yeah. Okay. All right, so mass of the block was 3 kilograms. Okay, so 3 times 10 sine 45 minus 1/2, the pulley's 1, A, minus the mu, 0.4, mass of the block 3, 10, cos 45 equals mass of the block A. All right, now it's just a matter of punching all this in. 30 sine 45, so 21.2 minus 1/2 A minus 0.4, it's 30 times cos 45, hopefully I don't mess up, 8.49 equals 3A. Okay, so 21.2 minus 8.49, 12.71, move this to the other side. Okay, so divided by 3.5, 3.63, yeah, reasonable. Okay, listen, and it should come out positive, right? Because I set everything to be the direction that it's moving. Okay, so if it comes out negative for some reason, you know you're going to mess up. Okay, if you set it up that way in advance. Okay, so just going to be that. All right, then they could go back and ask you for the tension. They could ask you for, I don't know, any random amount of things. Okay, but that's it. Okay, so again, it's the same thing over and over again. All right, you're just always doing the same thing, setting up your Newton's second law for the blocks, your Newton's second law for the pulley, knowing this, and then chunk it out, okay? Please make sure that you write this stuff, practice writing all this, because you're going to get points on an FRQ when you have those equations written out, okay? So make sure that you write those and don't just jump in, because you need to write those because that's going to get you a point, okay?